The title of my talk is taken from, what did I call my talk? It's like a young lady's illustrated primer to architecture and technical decision making. And it comes from, how many of you read the Neil Stephenson book? I'm disappointed with you guys. I know, yes, all right. The Diamond Age, yeah, best Stephenson book. It's so good. It's a cyberpunk story. Sorry, this mic is a little... it's about a future. I'm loud enough anyway. It's about a future where the world and our bodies are teeming with nanites. And everything goes to hell. So it's basically about buggy software. Oh, there it is. It's about buggy software when it's literally eating the world. Every CVC will tell you that this is happening. And I will tell you, it will soon be eating your brains. So in preparation for that day, I wanted to talk about technical judgment, also known as making good choices with software, and some tips for survival. Yes, making better choices. It's just kind of like the inevitable next step, right? Technical judgment is a thing that each of us does every day. Squeaky. Like wherever you are in the org chart or wherever you are in the software lifecycle, we're all constantly threading this needle between innovation and stability, between making things nimble for development and stable for our customers and our users. And making good choices with software is both really important and becoming more important every day. It's also getting harder every day. Like 5 years ago, you had a lot fewer choices. To prove it, I did some science for you. Produced an extremely sciencey graph. And if you just extrapolate that out a little, you can see that it will be literally impossible in just a couple of years. And you know that it's true because I have a graph. So how do we get here? Well, 15 years ago, we had the LAMP stack. Who here is old enough to remember running that in production? Yeah. Good stuff. Where architectural judgment meant choosing wisely between MySQL and Postgres. And you had 3 choices for the P, right? You had PHP, Python, and Perl. Perl's legit. Who here remembers CGI bin? Wow! Yeah, good times. Not really. And then about 10 years ago, we're like, well, this kind of sucks. This is not maintainable. And we started unpacking our monoliths, right? Into loosely coupled services connected by REST APIs. And I want to stress, at the time, this was confusing and hard, right? It seems really simple now, but we didn't know that that was the future. There were other development patterns that were competing for it, you know? Remember when we used to all had maintenance windows? That was the best practice. Doing a migration at midnight, we all thought that was a great idea because you had fewer users. It seems very basic now, but at the time it was really challenging challenging transition to a new way of thinking about infrastructure and software. But we did it to increase resiliency because we could see that doom was on the horizon. We got through it, we got used to it. Config management, virtualization, continuous delivery, all these things went from cutting edge to table stakes. And the last time that I was spinning up an infra from scratch was probably parse in like 2011, 2012. And it felt like there was a pretty reasonable standard set of choices and best practices that I should make based on the software and languages we were using. And over the last couple of years, right, founded my company last January, and I went, whoa. Like, I think I'm pretty good at this stuff. And I was paralyzed. Where do you even start? So this talk came out of that just like sense of, where do we even start out of this chaos? Like, what patterns should we really be paying attention to? And I do think that there are some pretty strong themes, right? Polyglot storage, polyglot persistence is now something that basically everyone does. We have to. Composable infrastructure is much more of a reality. Containers are growing up, kind of. We're gluing together more third-party platforms than ever before. And a lot of people haven't really started to grapple with the operational implications of that. It's not you're giving it to someone else and you can stop thinking about it. It's thinking about failure in an entirely new way. You are still responsible for the uptime of your service, even if it's powered by other services. There are fewer in-house engineering cycles than ever before. Engineering has always been scarce. It's only getting scarcer. So we're being forced to get much better at identifying the critical path and outsourcing the rest to experts. And what all of these trends have in common is that they increase complexity while simultaneously trying to tame it. It's like the classic XKCD thing, you know. I have 5 libraries. I will write a 6th one to like get rid of the other 5. Then it doesn't. It just adds a 6th one. Now, I think that this is actually a really exciting time to be in tech, especially because the open source world and the services world is really giving us access to the kind of tools that Google and Facebook, et cetera, have had for years. And, you know, we might think, oh, more choices are great, and it will be. Like, there's so much creativity in this explosion. There's so much energy. Eventually, this is going to be mature. It's going to be just as boring as a REST API. But in the meantime, it's actually really, really, really hard on the humans who are trying to navigate this space. That was well-timed. That's pretty cool, actually. Software sucks. I'll show you. What? Hardware sucks. Word. I like you. Okay, I unplugged it and plugged it back in. What do I try next? It can be cognitively overwhelming, right? There aren't a lot of best practices. A lot of the new solutions are not battle-hardened or production-ready, even though the salespeople and CEOs and CTOs will tell you that they are. Hi. No, I'm not throwing shade because I'm a vendor too. My shit is awesome and you should all use it and it will not go down. Yes. You know, there are incredibly few reliable narrators out there. Everybody's trying to sell you their own bleeding edge stuff. Well, that's cool. You gonna switch? Okay. All right, don't touch it. Nobody touch it. Oh, let me fix the monitor, though. No. It's super quick, I promise. System, God, I don't know how to... Desktops are hard, dude. Honey, will you help me with my... I'm kidding. I found it. I bring my own personal AV tech everywhere I go. Right, yeah. All right. Does this mean that you shouldn't use any of it? No. It just means that we need to think really carefully about our tolerance for risk and where to spend it. And I have a few tips for how to think about new technology adoption that can be useful, and most of it does boil down to risk management. And I think that these are the kinds of tips that your good senior engineers have mostly internalized. And a lot of times it just manifests as intuition. You know, we've all worked with people who, if they come into the room, like, we listen to them, right? Because they're usually right, even if they themselves can't completely explain why. And all I'm really trying to do here is unpack that a little bit and try to figure out what kinds of experiences are feeding their intuition. And we should start with the prime directive, which applies to every single one of us who works in tech. And as Captain Picard would say, your technology exists to serve your mission. It is never, ever, ever the other way around. What is your mission? I don't know. Maybe it's getting people healthcare, you know? Maybe it's, making the world more open and connected. Right. Or empowering developers to build better mobile apps. building software is never your mission, and even if even if your business is literally writing config management software or containers or databases, that's still not your mission. Your mission is just one layer abstracted, right? It's helping your customers build better missions. In fact, I think it's really much more helpful to think of software as the enemy. Honestly, right? Every piece of software, every line of code that you add to your systems adds fragility and potential points of failure. And every piece of software that you write yourself is something that other people will be debugging and spending their precious life years on until it goes away, which is why red diffs are the best diffs. And that is the best case outcome, right? Code is liability. The best code is no code. I think Peter Van Hardenberg is the first one who told me these are like PVH's 3 principles for software development. The best code is no code. The second best code is code that someone else writes and maintains that you get to use, and you can read the source when you need to, hardened by other people. And the worst code is anything else. It's easy to lose sight of this because we all love tech so much, right? But as a technical leader or as a technical senior engineer, it's your responsibility to make sure that decisions are made that serve your mission. And generally that means write as little software as possible to achieve your mission, which leads straight into the first principle, since we're counting from 0, which is that you should reuse solutions and components whenever possible. And this especially applies to storage systems. There's this great blog post written by Jessitron. I have a link to it on my last slide, where she has a spectrum of risk, and she talks about where you should do your experimentation and where you should be very conservative. And storage systems, look, the closer you get to laying bits down on disk, the more conservative you should be. The closer you get to the data layer, the more price, the more tax you pay for every additional component that you add, because you have to monitor it, you have to understand it, you have to be on call for it, you have to, it's really expensive to support storage systems. And another way of kind of putting the same way would be, as Dan McKinley says, these are 2 of my favorite people in the world, by the way. I have a link to this too. Are you all familiar with the innovation tokens blog post? Oh my God, you're gonna love this so much. He says, optimize globally, not locally. Am I working? Oh yeah, okay. If you optimize locally for every single problem, if you pick the perfect language and storage system for every little problem, you will end up with an incomprehensible nightmare of a system. Now, I feel like every other word that I say is context, but context matters. When you're a baby startup, local chaos is fine. You should be optimizing for experimentation and rapid iteration, because most startups fail, and it's usually not because they move too fast. Mine will too, I'm sure. I mean, this is why ops people rarely start companies. It's like we can see all the reasons that it's going to fail, It's hard to imagine. We're $1 billion company. Fuck you. But when your time horizon is longer, you need to shift your focus to maintainability, which means you must have some process for gating, for adding new major components to production, like a new language or a new database. It shouldn't be impossible, or you've achieved stasis. But it should be enough friction to make it intentional. At the very least, it should always cause people to stop and think and ask themselves, can I possibly solve this without introducing a new component? That's the whole point of friction. Also, you need to weigh the perceived benefits of the new technology against the relative gain. So, I'm sorry, if you're running Ubuntu and someone wants to add Red Hat, what is the answer? Fuck you. I can almost not even imagine a reason that you should add another operating system that is almost exactly like the old operating system. Or Postgres and MySQL. There are reasons, but you really have to think hard to come up with one. On the other hand, if you have large concurrency issues and you're written in Ruby, that change is inevitable. It's just a question of when. You may need to rewrite it in Go or in Erlang or something. Rewriting something from Ruby to Python? Again, you have to think pretty hard to come up with a use case for that. It is not, anytime you hear someone say, wouldn't it be cool if? The answer is usually no. But it's also important not to micromanage outside the critical path. You do want new ideas and new thoughts and new, creativity. You need to give, and the people who really feed on that, you need to feed their creative side. You need to value that side of what they bring to the org too, because that's where your new ideas come from. It's people like me who put a stop to them, and you need to balance it, which is why in Jessie Tron's post she talks about, developer tools are at the opposite end of the spectrum. What's the if somebody innovates too hard in the developer tools side, it's usually okay. At the very least, it's usually not taking production down with it, and if it is, you should think kind of hard about what your developer tools side looks like. If you have to add new components, start here. Choose boring technology. This is also in that Dan McKinley blog post. It's so good. And the reason is new software is software is always going to break in ways that you did not expect. It's like there's gremlins that live in it. Your old software had gremlins too, but you've been living with it for a while. You know where they live. What? Somebody said something funny and I didn't catch it. Damn it. Boring doesn't mean bad, right? We have this connotation with boring being bad. All it means, boring software runs the world, right? Boring is Java. I fucking hate Java, but it runs the world. COBOL? That's actually true. Boring means that its failure modes are well understood. It means that the ecosystem is rich and mature. For a language, this means rich library support. For databases, it means extensive stress testing in production and a robust user base. So you should use boring technology whenever you can. But the corollary is that the earlier stage or startup, or inside an established company, there are new teams, new skunkworks projects, new R&D all the time. This is your competitive advantage, right? This is how you disrupt the status quo. Parse could not have been built on any existing database at the time other than MongoDB. And we started when Mongo was 1.8. Remember that one lock? One lock. We grew up with the software, and we could afford that risk, right? Because nobody depended on Parse a long-ass time. Ugh, rest in peace. This is why, this is how you disrupt the status quo, by being more nimble, by taking greater risks, by having fewer sunk costs, by having nobody pay you for the old way of doing things. You have fewer humans, so you can get away with way more localized chaos and less discipline, more informal methods of, interacting and communicating. You have fewer customers, and they have way lower expectations of you. Low expectations are great. Use it when you can. Nobody's competitive advantage is in rewriting cron, right? If you're rewriting cron, you're doing it wrong. Maybe, unless your business is disrupting cron. Jenkins kind of did that, huh? Whatever. Some good reasons for supporting new components. It's critical to your mission. Duh. If you're replacing or upgrading, okay, cool. But commit to a timeline and get rid of the old one. You have the worst of both worlds if you have to maintain the old one and the new one, right? It's totally legit to give preference to something because your team understands it. There will always be gremlins in software. Knowing where they live is a big advantage. You should not choose a new component because Hacker News likes it or doesn't like it. Or because of vendor benchmarks, because all vendors lie. Sorry, selectively tell the truth so that we look really pretty. And don't forget to ask, how good is the community? Because quality communities make software much more likely to succeed. And this is something that Chef did really well. I used to be a Puppet user. At the time, there was not a lot of difference. And I went with Chef because they were so nice. That's right. Yay. And lastly, almost all of this advice basically boils down to considering the operational impact and life cycle of your code and of the technical decisions that you make, because honestly, like you can round down to 0. Developing software costs 0 compared to maintaining it over its life cycle. The best engineers are the ones who really internalize this and do it instinctively, I think. Outsource as many ops problems as you can. Make it not your problem. Anything that is not core to the success of your business, try to avoid doing it yourself. Because the problems that are core to your business, you're going to need to keep in-house, right? You need to keep them close. So save your precious, scarce engineering cycles and your life's blood for those. And remember that culture can do a lot of heavy lifting for you here. You know, you can either make a lot of rules and like write all of the, plugins for Git to like try and, or, you can celebrate things. You can make it part of your performance cycle. You can make sure that, operational excellence is something that we pay attention to as an organization. If you celebrate the developers who remove code, who deprecate things, who simplify and refactor and reduce the duplication just as much as you celebrate the developers who build features and ship things, red diffs are just as good as green diffs, sometimes better, you'll get more of it. It's harder to recognize it. It's absolutely harder. You have to ask the right questions to tease out this information, but it's not impossible. And I feel like I say this in every single talk I've ever given, but be careful what you're praising, because the patterns that you call out and celebrate in your culture are the patterns that will get repeated, right? And if you praise the wrong things, like if you only find yourself praising people when they're up overnight, tending to something that was down, people get the message. This is what we value. If you're intentional about this and you only praise publicly when people fix things so that they didn't stay up all night, like this is a tricky, it's not tricky, but it's just like, you can thank people privately. Thanking privately is different than praising publicly. And the things that you praise publicly are the things that people will keep doing. And then you don't need so many rules. Rules suck. So this is like your technical decision-making manifesto. Serves the mission, reuse it, create some friction for adding new things, but appropriate to your level. You don't want it to be impossible. You don't want to stomp on creativity. Choose boring tech when you can. Bend your risk tokens on your key differentiators. And the longer you survive, good for you, the more operational impact trumps everything. People are like, oh, what's going to happen up, when software engineers are doing it? I'm like, nothing's happening to the profession of operations engineering anytime soon. But we have to change. Change is good. Most startups fail, but mostly they fail for lack of traction or product market fit. Not because you chose the wrong programming language or the wrong editor, for Christ's sake. But think about it. 15 years ago, somebody was giving this exact same presentation in PowerPoint with a suit on, but they were complaining about how they used to just have C and the world was simple. Now they have to choose between C and C++, Perl, Java, Python, kids these days. Really doesn't matter. This is a constant battle, and it always feels terrifying. It always feels like we're on the precipice of disaster. Well, we always are, but we catch up. So I'm not saying these choices don't matter. They do, but where they matter is not where we feel like they do. They matter. Thank you. I'm on two more slides. They matter in how, not whether you succeed or fail. Have you seen LinkedIn's develop? Sorry. Find me afterwards with a beer to talk shit. But the choices that you make can have a huge impact on how quickly you can move, how much technical debt you accumulate, and most importantly, how happy the engineers on your team are, and whether they want to stay, and whether they recruit their friends to come work with them. That's what's hard. That's where these choices matter. Making choices that make people happy matters. So cheer up, enjoy it while you can, because these are already the good old days. Thank you. Oh, sorry, I want a standing